Welcome back. My name is Darren Thomas, and I am the Director of Educational Research Techniques. In this particular video, we're going to be looking at fraud detection, and we're going to be using Python, and we're going to be focusing on resampling. So let's go ahead and see what we can learn. So the challenge with fraud detection is you're trying to identify outliers, because that's what fraud is, outliers that indicate inappropriate behavior based on the context, credit cards, health fraud, etc. And one of the main challenges of fraud detection is that you have a handful of bad cases and the majority are good cases, probably above 99%. And so when you're trying to model for these and you're trying to make a model to identify them, random guessing will give you accuracy to 97, 98% of the time. And so you have to find ways to deal with being able to overemphasize these outliers when you are trying to create your analysis. So what we're going to do now is we're going to look at some of the basics of how to do this using some common techniques here. And so this video, we're going to be focusing primarily on resampling. And so how you can boost the number of fraud cases in order to prepare your model. Now, of course, there's lots of different ways to do this, and we'll be covering some of those in the future, but we're going to do some basic ideas first. Okay, so we are going to start by loading our data. And so these are the different libraries we're going to be using: Pandas, NumPy, Matplotlib for making visuals, and SMOTE, which stands for, we're going to learn down here, Synthetic Minority Oversampling Technique. We will talk about that more in a minute. Right here, we just load our data set right here, and then we print the information in this line right here. So we got to go back and do this. Okay, there we go. All right. So here's our data. The data is kind of dumb data. You can see the variables, the column names don't really tell you anything. Right here are the two main stars. The amount, that's how much the person you used their credit card for as an example. And the class tells you if it's fraud or not fraud. So 1 for fraud, 0 for not fraud. But again, this is just for practicing purposes. We're not really going to be using real data here. All right. Now we're going to be looking at the occurrences of fraud versus no fraud. And so to do that, we're going to be using the following data right here, are the lines of code. So in this first line right here, we're just having a breakdown of the class. So again, the class variable is variable number 30. And so right here in this previous line, and we just want to see how many cases of fraud, which is going to be a 1. And how many cases of not fraud do we have? And then we print it right here. And then in this next line of code, we break down, okay, what percent of our data is, fraudulent versus not fraudulent. So go ahead and run this. So you can see right here that we have 5,000 cases that are not fraud, 50 cases that are fraud. Again, this is very, very common. So about 99% of our data is not fraud, and a little less than 1% of our data is fraud. Again, this is very, very normal. So like I said, if you just guess randomly, you could be right 97, 98, 99% of the time. And that's where training a model becomes meaningless, because your model doesn't really help you to pick out those handful of cases where fraud is present. Now, let's do a little bit of data preparation before we go to our next step. And so I'll explain what we're doing right here. All right, so what we're doing now is that we're taking all of our X data. That's going to be columns 1 to 30. Now remember, with Python, the last number doesn't really count. So we're really taking columns 1 to column 29. Also remember that Python is 0 index, so we're not taking the first column. 1 means the second column. And then the number 30 means the 29th column. So if that's a little confusing, we're going to start right here with variable 1, because the first one is like user ID number or something. We're starting right here with variable 1, v1, and we're going all the way down here to variable 29, amount. That's what we're doing. And so this means the row, I guess. Yeah, this means takes all the rows. And this right here means take the columns. And so then the next thing that we do is we're going to convert this into a NumPy array right here, make it a float. And then we're going to take just that last column with this code. So again, this right here is telling us to take all of the rows. And this is saying to take column number 30, basically. And we're going to convert this into a NumPy array as well. So we're going to go ahead and do this. And there's really nothing to see once you run it, unfortunately. If you really desire to, we can print it real quick. You can see that's the X values right there. And then the Y values. You can see the Y values are just zeros and ones, as to be expected. And now we're going to make our visualization to try to get an idea of what's going on with this data. So let's go ahead and take a look at that. So we're going to pull this, and then what we're going to do is we're going to compare this when we do our resampling using Smote. All right, so this is a little complicated, but let me see if I can make this simple. What we're doing here is we're making two scatter plots. In this first scatter plot, this is what's happening. We're telling for X, we're going to subset Y values when they equal 0. We're going to take the first column of data for our X-axis. And then right here, we're going to subset from X when Y equals 0 and take the second column of our X data. That's what we're doing here. So what's happening here is that we're going to plot all the cases of fraud when they're 0. And we're going to take the first column of data, V1, and the second column of data, V2. That's what's happening there. And then we're going to label this as class 0. And then we got alpha in line with right there. And then we repeat this process for when fraud is true. So notice how instead of a 0 being here as before, we have a 1 now. So when Y equals 1, take the first column of data from X. When Y equals 1, take the second column of data from X. This is going to give us our X and Y axes for that. Notice how the numbers after the comma are the same each time inside the little subset, because we're taking the first and second columns of data for mapping purposes. Now, for our second scatter plot right here, we're going to call it class 1. That means true. And then the alpha in the line with is the same. And then we're going to make sure it's color red. So let's go ahead and run this. So you can see that we have a majority of blue cases. That's cases where there is no fraud. And we have sprinkled among those a handful of true or positive cases of fraud. And so this is giving us a visual of what we're looking at. Remember, this is basically V1, variable V1 in our data set, column V1. This is column V2 right here. That's all that is. We picked the first two. We could have picked any combination of variables. It doesn't matter, but this just provides us with a picture. Now, as we get close to the end here, what we're doing now is going to be using the Smote resampling. So that stands for synthetic minority oversampling technique. And so what this does is that there are different ways that you can either oversample or undersample. Undersampling is when you reduce the values of X that you have so that they kind of match the values for Y. So in our example, we have 5,050 overall examples. 5,000 were false, 50 were positive. We could reduce the false down to say 175, and then that way our data is balanced. Now the problem with that is you're throwing away a lot of data, which of course people have problems with that. So that's undersampling. Oversampling is when you boost up the number of Y values, so you duplicate them, if you will. Now again, the problem with that is you're training your data on duplicated values, which has problems as well. And so Smote is kind of an example of oversimplifying, in that what it does is that it uses nearest neighbor to generate synthetic or false positives, or not false positives is really bad in this context, generate synthetic positives, if you will, to based on nearest neighbor, which is of course a machine learning algorithm that you can use for determining things. And so in other words, if you were to map these in some sort of a space, values that are near other positive values will be created that are also positive, and so you can boost it up. And so that's one way to address the challenges of having a handful of fraud cases. Now, as we move into future videos, we're going to see things about balance weights and other ways that you can address this. But SMOTE is one way or one tool that you can use, and the most appropriate tool just depends on the situation you're facing. We're not going to be proponents of any particular example or way of doing things. All right, so here's our code. We start by creating an instance of SMOTE. That's our first thing. And then we resample from we call them X resample, Y resample. And then we use our method, and we use our method fit underscore resample. This is our X and Y values that we created earlier. And then here we're just going to print what they look like. So let's go ahead and do this. All right. So what you can see here, this right here is our original distribution of class. So we have 5,000 that were not fraud and 50 that were. This right here is our distribution using SMOTE. So you can see clearly that now we still have the same 5,000 that are not fraud, but through using SMOTE, we were able to boost up the Y values and Y resampled to be 5,000 as well. So this is a much more balanced training set, if you will. And here's the total count for the two sampling methods. 5,050 for our original data set, and now 10,000 for our resampled data set. And remember, resampling means that it just kept generating additional examples of fraud using nearest neighbor. Now let's just take a picture of this so we can see what it looks like, and we'll wrap this video up. So we're going to go ahead and take a look at this. This code is exactly the same as the last data visualization. The only thing that is different is where we're pulling our data from. That's it. So no need to re-explain this. And so now you can see we're much more balanced. This is our new resample data, way more examples or instances of fraud. And in case you forgot, here's our original. So again, is SMOTE the best way? I cannot comment on that in particular. However, we now have a much more balanced data set that we can use for model training. Now, remember also that you don't want to do these resampling techniques on your test data. This is only for your training data. So you have to keep that in mind, that you need to make sure you separate these things beforehand. Otherwise, you are going to be testing your final model on synthetic data, which is not considered best practices. So what we're going to do now is summarize what we learned and finish this video. So in this video, what we did was this. We looked at an example of sampling when dealing with data for the purposes of fraud detection, which is where you're looking for outliers that indicate some sort of illicit activity was going on in most situations. So we started by, of course, loading the various packages or libraries that we needed, and then taking a quick look at the data. So this is all dummy data, so the labeling of the columns has no true meaning, but this is what we have. Then we took a quick look at our data. We looked at, you can clearly see the number of instances of non-fraud at 5,000, the instances of fraud at 50, and then the difference of 99% are not fraud, about 1% are fraud. Then we prepared our data for a future purpose of using the SMOTE library. We made a quick picture of it as well. You can see here's the original data. Then we use SMOTE, synthetic minority oversampling technique, which allowed us to boost the number of Y values we have using nearest neighbor algorithm to try to generate synthetic data. And so we went from having only 50 fraud cases to 5,000, which is a much more balanced data set that will make it much easier for us to train our model. And then we we made the data visualization again to give you a picture of what it looks like, and there it is. So that's it for this video. I want to thank you so much for listening and watching. My name is Darren Thomas. I am the Director of Educational Research Techniques. Take care and have a great day.